Yes. Hello dear students. So we are continuing yesterday's topic. So yesterday we have discussed some basic concepts of thermodynamics, that is system and surroundings and boundary surface, right? So this all will be explained with the help of simple diagram. Any specified portion which is under our observation, that is called system. The rest of the part is known as surroundings, right? So this is the surroundings. Then the system plus surroundings. System plus surroundings, that will be universe, right? System plus surroundings will be universe, right? So whatever is the system we may consider, so that is present at temperature, pressure and volume. These are the thermodynamic states. So these thermodynamic states do not change with time. So hence the system will be present at thermodynamic state. If any one of the property will be changed, that will be involved in thermodynamic process, and various thermodynamic properties are there. So that are somehow intensive properties and extensive properties. Thermodynamic properties that are intensive and extensive, right? Intensive property, extensive property. Weight dependent is extensive property, weight independent is intensive property. So the various properties we are segregated based on that dependent of weight or dependent on number of moles, somehow extensive and intensive properties, and also the ratio of two extensive properties. The ratio of two extensive properties becomes intensive property, right? So this all will be covered in the previous class, right? In addition to this, we are going to discuss one more concept, that is about state functions and path functions, right? So putting state functions, and path functions, right? So what are the state functions or path functions, or we may call as even state properties and path properties, right? So two names are there, one is state, other one is path, pathway and state. So depending on the terminology, so we can get two different kind of properties, so that will be discussed, right? So now here we have to consider one system, right? So this is the system A, right? System A is converted to system B. This is the system B. So what was the process is involved in this? Means the system A is converted to system B through a pathway 1. There is a one pathway to conversion of system A to system B. So then other pathways also will be there. So means some other pathway, that is pathway number 2. Then some other pathway is there, pathway number 3. Then other pathway also will be there, pathway number 4. Means conversion of one system to other system, there are many number of pathways are there, right? So we have to discuss about those pathways, right? So there are 4 pathways are there. The system A is converted to system B, but the system A is present at temperature is T1, pressure is P1 and volume is V1. These are the state variables, right? State variables are thermodynamic properties. So the system A is present at T1 temperature, P1 pressure and V1 volume. This will be converted to system B, means B is at temperature is T2, pressure is P2, volume is V2, right? Any property now we have to consider, right? Any property we have to consider, right? So that is the property. That property is depends on. So these are the called as initial states, right? So these are the called as final states. Whatever is the property we may consider, that is depends on initial states of the system and final states of the system. Initial and final state, and independent on, right, pathways. Irrespective of pathways. How many pathways here? 4 pathways are there. So that is independent on pathways and depends on initial states and final states of the system. What is the initial temperature? What is the final temperature? What is the initial pressure? What is the final pressure? What is the initial volume? What is the final volume? So therefore the property is said to be state function, right? So therefore those properties are called as state functions or state properties, right? any property which is depends on initial states and final states of the system and independent on pathways. Such functions are called as state functions. The example of state functions means, right? So these are temperature, pressure, volume are the state functions, and all the thermodynamic properties. All the thermodynamic properties. What are the all the thermodynamic properties means? As we discussed, internal energy is E, then enthalpy is H, entropy is S, Gibbs free energy is G, Helmholtz energy function. These all are thermodynamic properties. All the thermodynamic properties are acts as what? State functions. State functions. Remember that this all will be depends on initial states of the system and final states of the system and independent on pathways. There are 4 pathways are there. Whatever is the pathway we may consider for conversion of system A to system B. So irrespective of that pathways, what are the initial and what are the final states, that becomes the state functions. These are the examples. Then coming to the path functions, right? Path functions, right? So what are the path functions? What are the path functions? That is quite opposite to the state. Means whatever is the function we may consider, right? The function which is depends on pathways. How many pathways are there? There are 4 pathways are there, and independent on initial states and final states of system. These are called path functions, right? So state functions are dependent on initial and final states, independent on pathways, right? Coming to the part of path functions, these path functions are depends on pathways and independent on initial and final states, right? So there are 2 path functions are there, right? Example of path functions, one will be heat, the other will be work. Heat will be denoted with Q, work will be denoted with W. These are the 2 path functions. These are the thermodynamic properties or state functions. Now we are going to get the relation between all the thermodynamic properties and state and path functions, right? So between the state functions and path functions are all thermodynamic properties and path properties. So that is called thermodynamics, right? So in further what we are going to getting the information regarding these functions means we have some thermodynamic properties. How these thermodynamic properties will be changes with respect to the pathways, right? How which will be depends on path means, for example, heat is there, right? As I said earlier, heat is either observed or heat is released, right? So whatever is, for example, in this case, heat is released, right? How much amount of heat is released through pathway 1, that may not be same in pathway 2. In both situations, both pathways means pathway 1, 2, 3, 4, some heat will be released, that heat may not be same. Hence, that is depending on pathways. That is depending on pathways, right? And independent on initial and final states. Whatever is the initial and final states will be there. So that properties are depends on only pathways and also work. For example, in this pathway some work done will be there, pathway 1. That work done may not be equal with other pathways. So hence these 2 are depends on pathways only. They just path functions means you have to remember heat and work are the path functions. Remaining all thermodynamic properties are what? State functions, right? So here just remember that state functions are depends on initial states and final states, independent on pathways. Path functions means depends on pathways, independent on initial and final states, right? So this we may explain with the help of an example, right? So these all are what? State functions and path functions, right? How the state functions and path functions are independent on pathways and dependent on initial and final states, right? If you may consider one example, right? Integral of ds, right? D means nothing but change of entropy, S is entropy, right? We have initial state is initial state to final states, not mentioning whether that may be temperature or pressure or volume, right? So this initial to final. Now this will be integral of initial state to which will be following a pathway x, whatever is the x value, right? So one pathway will be there, x pathway of ds plus integral of x pathway to final state integral ds. Means initial state to final state, there is a one pathway is there. What is the pathway here? Followed by x. X is a pathway. Anything we have to consider in this x, we'll get some result, right? Now the same ds in change in entropy, initial state is there, final state is there. This will be, now it may depends on, right, initial state to pathway will be y into ds plus integral of pathway is y to final state, right? Y to final state into ds. Here the pathway will be x, here the pathway will be y, right? Just I am indicating those pathways, right? Initial state 2, what about the pathway here follows? X. Then initial state 2, what about the pathway here follows? Y, right? So y pathway will be there, then x pathways, different pathways are there. Whenever we may get that integration part of this function, so both are giving same value only, both are giving same result. Hence this is the function ds is does not depends on pathways. Whether we may follow pathway x or we may follow pathway y, the overall result will be same, because that is depends on initial and final state only. What are the initial, what are the final? What are the initial, what are the final? So hence these properties are called as what? State properties, right? Or state functions, right? State functions. Similarly, we may consider, right? So one of the path property. So we know that q and w are the path properties, right? So therefore integral of dw, then initial state to final state, initial state to final state. So here we may follow one pathway, that is initial state to pathway x of dw plus then integral of x to final state of pathway dw. Here we will get some result, right? So means we have to follow one pathway, that is the x. In other case, so the pathway will be changed, that is integral of initial state to final state of dw, that is equals to integral of initial state to, now here pathway will be y dw plus integral of y to final state of dw. What here we have changed? The pathway will be changes. Here what about pathway? X is a pathway. Here what about pathway? Y is a pathway. Whenever pathway will be changes, the obtained values, right, different result will get. Different result will get. We are not getting same result because pathway will be different, means this is a function dw is depends on pathway. W is a work function that is depends on pathways, hence we are getting different result. Therefore this we may call as path function, right? See how it will be clear. Any property you have to consider, in both the cases we have changes pathways, right? So here we have changes pathways, so therefore we are getting same result, means that is depends on initial and final states and independent on pathways. This is state functions are what? Independent on pathways, right? Independent on pathways. Whether we may change the pathway, we are getting same result only. But here whenever we change the pathway, so this is dependent. Pathways are dependent on pathways. Path functions will be depends on pathways. Only remember that two path functions are there, heat and work. Then remaining all thermodynamic properties are state functions. What is the relation between them? That we are going to discuss in our thermodynamic. Whatever they mentioned syllabus, right, that we are going to explain with the help of these functions, state functions and path functions. All thermodynamic properties are becomes what? State functions, right? So then heat and work will be path function. Whatever the relation between these means, how the heat energy will be exchanged between the system to surroundings. What will be the change of internal energy, change of enthalpy, change of entropy, change of Gibbs free energy, change of Helmholtz energy function. All information we will get, right? So this is about regarding state functions and path functions, right? So in addition to this, In addition to this, some terminology is there, means, so some terms are there in our thermodynamics. Definitely we have to understand the terms. With the help of that we can understand the further subject easily, right? So means, so we know that right now we are in hot condition, temperature will be very high, so therefore we have to discuss about heat. Heat is denoted with Q, right? Heat. So simple thing, how we have to define that heat. Heat is a ordered form of energy or disordered form of energy. Simple thing, హాట్ వాటర్ ఒక మగ్లో తీసుకొని బెంచ్ మీద పెట్టేసేయండి. టెంపరేచర్ ఏ డైరెక్షన్లో సరౌండింగ్స్కి ట్రాన్స్ఫర్ అవుతుందో చెప్పగలుగుతామా? ఇన్ ఆల్ 360 degrees టెంపరేచర్ విల్ బి transferred. Means there is no particular order. There is no particular order. Hence heat energy is a what? Disordered form of energy. Right? So that we have to remember first. Heat is a disordered form of energy. It is disordered form of energy. Disordered form of energy. Heat is what? Disordered form of energy, right? So what is meant by heat definition? Right? The energy, whatever is energy which is exchange, the energy which is exchange between system and surroundings, system and surroundings, surroundings due to temperature difference, due to temperature difference, that is called heat. Means energy exchange will be taking place between the system and surroundings. That exchange of energy will be with respect to what? Change in temperature. Change in temperature, right? So here we consider one terminology, that is the system and surroundings, all those things, right? So this is the any specified portion which is under our observation, that is called system. The remaining part is what? Surroundings, right? This is the surroundings, this is the surroundings, and here surroundings, right? System is there and surroundings is there. Now we have to apply the three conditions, right? So what are those three conditions means, right? So the condition number 1, right? If temperature of the system is greater than temperature of the surroundings. System యొక్క టెంపరేచర్ ఎక్కువ ఉంది, సిస్టమ్ టెంపరేచర్ ఎక్కువ ఉంది, అప్పుడు హీట్ ఎనర్జీ ఎక్కడి నుంచి ఎక్కడికి ట్రాన్స్ఫర్ అయిపోతుంది? సిస్టమ్ టు సరౌండింగ్సా, సరౌండింగ్స్ టు సిస్టమా? మనం ఏం చదువుకున్నాం? న్యాచురల్గా జరిగే ప్రాసెస్లు ఏంటి? స్పాంటేనియస్ ప్రాసెస్లు. హీట్ ఈజ్ ట్రాన్స్ఫర్డ్ ఫ్రమ్ వేర్ టు వేర్? హై టెంపరేచర్ టు లో టెంపరేచర్ ఈజ్ ఆటోమేటికల్లీ, రైట్? ఎప్పుడైతే సిస్టమ్ టెంపరేచర్ ఎక్కువ ఉందో ఏమవుతుంది? అప్పుడు హీట్ అనేది సిస్టమ్ నుండి సరౌండింగ్స్కి ట్రాన్స్ఫర్ అయిపోతుంది. మరి అప్పుడు సరౌండింగ్స్ అనేది హీట్ని గెయిన్ చేసుకుంటుందా, లూజ్ చేస్తుందా? ఎస్, సరౌండింగ్స్ ఈజ్ గెయినింగ్ ఎనర్జీ, right? So here surrounding is gaining. When surrounding is gaining, right, what about the system? System is losing. ఎంతో కొంత హీట్ ఎనర్జీని సరౌండింగ్కి ఇచ్చేస్తుంది కదా, అప్పుడు సిస్టమ్ ఏమవుతుంది? లూజింగ్ ఎనర్జీ, రైట్? సో దేర్ ఫోర్ వెన్ ఎవర్ టెంపరేచర్ ఆఫ్ ద సిస్టమ్ విల్ బి మోర్, టెంపరేచర్ ఆఫ్ ద సిస్టమ్ విల్ బి మోర్, సిస్టమ్ లాస్ట్ సమ్ అమౌంట్ ఆఫ్ ఎనర్జీ, system lost some energy. Whenever system lost some energy, that will be denoted with what? Negative. System will be lost some amount of energy when system temperature will be more, right? Right. So the second condition is there, the temperature of the system, right? The temperature of the system is less than of temperature of the surroundings. ఇప్పుడు ఎట్ సైడ్ ఎక్కువ ఉంది టెంపరేచర్? సరౌండింగ్స్ టెంపరేచర్ ఎక్కువ ఉంది, అప్పుడు ఎటు నుంచి ఎటు పోతుంది హీట్ ఎనర్జీ? ఎనర్జీ విల్ బి exchange between the system and surroundings from high temperature to low temperature. Mari high temperature to low temperature ante this is the condition 1. What about this system to surroundings? This is the condition number 2. Ante surroundings nunchi konta heat energy evaru absorb cheskuntaru? System absorb cheskuntundi. Means system is gaining, right? So hence system is absorbing some energy, right? Some heat energy or energy, right? When system is gaining means therefore Q is equals to what? Positive. when Q is heat energy is positive, it is a heat only. Heat is what denoted with Q. When Q is positive, Q is negative. This we have to understand clearly, right? సో సిస్టమ్ ఉంది, సిస్టమ్ ఎనర్జీని గెయిన్ చేసుకున్నది మీన్స్ పాజిటివ్. అదే సిస్టమ్ ఎనర్జీని ట్రాన్స్ఫర్ చేసింది. ఈ గెయినింగ్ అండ్ లూజింగ్ దేనివల్ల? టెంపరేచర్ డిఫరెన్స్ వల్లనే. వేరే పారామీటర్స్ ఎఫెక్ట్ కావద్దు, ఓన్లీ దట్ ఈస్ డ్యూ టు టెంపరేచర్ డిఫరెన్స్. దెన్ ఓన్లీ వి మే కన్సిడర్ యాజ్ హీట్ ఎనర్జీ. సో దట్స్ వై ఐ మెన్షన్ దట్ ఎక్స్చేంజ్ ఆఫ్ ఎనర్జీ, ఎనర్జీ ఎక్స్చేంజ్ బిట్వీన్ ద సిస్టమ్ అండ్ సరౌండింగ్స్, దట్ ఈస్ డ్యూ టు టెంపరేచర్ డిఫరెన్స్ ఓన్లీ. టెంపరేచర్ డిఫరెన్స్. సో రెండు టెంపరేచర్ సేమ్ ఉంటే దట్ ఈస్ ద థర్డ్ కండిషన్, రైట్? So for example, temperature of the system will be equals to temperature of the surroundings. Both the temperature will be same when temperature of the system is equals to temperature of the surroundings. Therefore, there is no exchange of heat energy between the system and surroundings. No exchange of heat energy. No exchange of heat energy. That is the process we may consider as thermal equilibrium. Thermal equilibrium. ఈ కండిషన్ ఏమంటున్నాం? థర్మల్ ఈక్విలిబ్రియం. ఏవైనా రెండు సిస్టమ్స్ థర్మల్ ఈక్విలిబ్రియంలో ఉన్నాయంటే దాన్ని దేంతో ఇండికేట్ చేయొచ్చు? ఆ రెండు సిస్టమ్స్ టెంపరేచర్స్ సేమ్ అని చెప్పొచ్చు, రైట్? Or else one system is thermally equilibrium with surroundings. అప్పుడు ఏమనొచ్చు? సిస్టమ్ సరౌండింగ్ టెంపరేచర్ విల్ బి సేమ్ అని చెప్పొచ్చు, రైట్? ఫర్ ఎగ్జాంపుల్, వాటర్ at 100 degrees centigrade. Environmental temperature is 27 degrees centigrade. Now in summer hot condition it will be approximately 40 around, right? But generally we may consider room temperature is 25 or 27 degrees centigrade, right? So hot condition means 100 degrees centigrade, surrounding will be 27. Some amount of heat energy is transferred to the surroundings. Whenever system is going to lose some amount of energy, so that will be denoted with Q is negative. మరి ఎక్కడి వరకు ఎంతసేపు ఎనర్జీ అనేది ఎక్స్చేంజ్ అవుతూ పోతుంది? when both the temperatures should be same. ఇన్సైడ్ అండ్ అవుట్ సైడ్ టెంపరేచర్ సేమ్ అయ్యేంత వరకు హీట్ ఎనర్జీ అనేది ఎక్స్చేంజ్ అవుతూనే పోతుంది. అది ఐదర్ సరౌండింగ్స్ నుంచి సిస్టమ్ అయినా జరగవచ్చు, లేదా సిస్టమ్ నుంచి సరౌండింగ్స్కి అయినా. సో ఎప్పుడైతే ఆ రెండు సేమ్ టెంపరేచర్స్ అయినాయో ఆ కండిషన్ ఏమంటున్నాం? ఈక్విలిబ్రియం కండిషన్ అని అంటున్నాం. అప్పుడు ఎలాంటి ఎక్స్చేంజ్ ఆఫ్ ఎనర్జీ జరగదు. సో దేర్ ఫోర్ హెన్స్ దట్ ఈక్విలిబ్రియం ఈజ్ పర్టికులర్లీ నోన్ యాజ్ వాట్? థర్మల్ ఈక్విలిబ్రియం. బేస్డ్ ఆన్ దిస్ థర్మల్ ఈక్విలిబ్రియం కండిషన్ we are going to explain zeroth law of thermodynamics. What is meant by zeroth law of thermodynamics? That will be explained with the help of these conditions only, third condition only. Clearly remember, first condition means temperature of the system will be more than compared to surroundings. At that time systems losing some amount of energy to the surroundings, right? So some amount of energy will be giving to the surroundings, system will be losing means hence that will be denoted with Q is negative. మరి సెకండ్ సిచ్యువేషన్ అంటే సరౌండింగ్స్ టెంపరేచర్ విల్ బి మోర్. అప్పుడు సిస్టమ్ ఏం చేస్తుంది? సరౌండింగ్స్ నుంచి గెయిన్ చేసుకుంటుంది, రైట్? సో వెన్ సిస్టమ్ ఈస్ గెయినింగ్ సమ్ అమౌంట్ ఆఫ్ హీట్ ఎనర్జీ ఫ్రమ్ ద సరౌండింగ్స్, రైట్? ఎట్ ద టైమ్ క్యూ ఈజ్ పాజిటివ్, రైట్? మరి రెండు టెంపరేచర్స్ సేమ్ ఉన్నాయి, దెర్ ఈజ్ నో ఎక్స్చేంజ్ ఆఫ్ ఎనర్జీ. ఆ కండిషన్ ఏమంటున్నాం? థర్మల్ ఈక్విలిబ్రియం అంటున్నాం. ఈ థర్మల్ ఈక్విలిబ్రియం కాన్సెప్టే జీరోత్ లా ఆఫ్ థర్మోడైనమిక్స్ కోసం యూజ్ చేస్తాం, రైట్? సో దిస్ ఈజ్ అబౌట్ హీట్ ఎనర్జీ. అండ్ వాట్ ఆర్ ద యూనిట్స్ ఆఫ్ హీట్? What are the units of heat, right? So heat will be expressed in units, right? Particularly in physical chemistry, definitely we have to identify the units whenever you are doing the questions, particularly physical chemistry questions, right? So ఏం లేదు, మనం నెక్స్ట్ థర్మోకెమిస్ట్రీ చదివేటప్పుడు చెప్తాం క్లియర్గా. ఒక ఎనర్జీ ఏమో జౌల్స్లలో ఎక్స్ప్రెస్ చేస్తాడు, ఇంకొక ఎనర్జీ కిలో జౌల్స్లలో మెన్షన్ చేస్తాడు. ఆ రెండు ఆప్షన్స్ యాజ్ ఇట్ ఈస్గా ఫార్ములా సబ్స్టిట్యూట్ చేస్తే మనకు ఆన్సర్ వస్తుంది. ఆ ఆప్షన్ కూడా క్వశ్చన్లో ఆప్షన్లో ఉంటుంది. సో మనం ఏం చేస్తాం? ఆల్రెడీ వచ్చింది కాబట్టి పెట్టేస్తాం. బట్ యూనిట్ కన్వర్షన్ ఈజ్ వెరీ ఇంపార్టెంట్, రైట్? సో రెండు సేమ్ యూనిట్స్ మెయింటైన్ చేయాలి. ఒకటి జౌల్స్, ఒకటి కిలో జౌల్స్ ఉంటే సబ్స్టిట్యూట్ చేయడానికి లేదు. ఐదర్ జౌల్స్ని కిలో జౌల్స్కి కన్వర్ట్ చేయాలి, లేదా కిలో జౌల్స్ని జౌల్స్లో కన్వర్ట్ చేయాలి. మరి దేనిలో కన్వర్ట్ చేయాలనేది ఎప్పుడు తెలుస్తుంది? ఇచ్చిన ఆప్షన్స్ని బట్టి తెలుస్తుంది. ఆప్షన్స్ని బట్టి ఆప్షన్స్ కిలో జౌల్స్ ఉంటే జౌల్స్ని దేంట్లోకి కిలో జౌల్స్కి కన్వర్ట్ చేయాలి. ఒకవేళ ఇచ్చిన ఆప్షన్స్ జౌల్స్లలో ఉంటే కిలో జౌల్స్ని దేంట్లోకి జౌల్స్లోకి. రెండు జౌల్స్ కిలో జౌల్స్లలో క్వశ్చన్ ఉంది, కానీ ఇచ్చింది దేంట్లో ఉంది? క్యాలరీస్లలో ఉంది. మొత్తం ఆ జౌల్స్ ఆర్ కిలో జౌల్స్ని దేనికి కన్వర్ట్ చేయాలి? క్యాలరీస్కి. సో దెర్ ఈజ్ ఎ వెరీ ఇంపార్టెంట్ థింగ్. So we have to focus on the unit conversion, right? So I will explain some parameters are there, what are the units, how the relation between all those units, unit conversions also I will explain in detail, right? Therefore units of heat energy is joules, right? Next calories, next ergs, right? Joules, calories, ergs. Next kilojoules, kilocalories, right? Kilo ergs. K for kilo. These all are units of heat energy. హీట్ అంటే ఏం లేదు, టెంపరేచర్ డిఫరెన్స్ ఉండాలి, ఎనర్జీ ఎక్స్చేంజ్ జరగాలి. టెంపరేచర్ డిఫరెన్స్ ఉండాలి, ఎనర్జీ ఎక్స్చేంజ్ జరగాలి. ఆ ఎనర్జీని ఏమంటాం? హీట్ ఎనర్జీ అని అంటాం. టెంపరేచర్ సేమ్ ఉన్నాయనుకో, నో ఎక్స్చేంజ్ ఆఫ్ ఎనర్జీ. యాజ్ హియర్ వి డిస్కస్డ్, వెన్ ఎవర్ ద టెంపరేచర్స్ ఆర్ సేమ్, దెర్ ఈజ్ నో ఎక్స్చేంజ్ ఆఫ్ ఎనర్జీ. There is no exchange of energy whenever temperature difference is there. So that's why heat is a disordered form of energy. It is exchange between the system and surroundings that is due to temperature difference, that is called heat energy, right? That is called heat energy, right? So then coming to the part of one more parameter, that is called work, right? So these are the units, right? Then this is very very important of terminology, that is work W. వర్క్ అంటే ఏం లేదండి, వెరీ సింపుల్, రైట్? సో ఏదైనా ఒక ఆబ్జెక్ట్ని, రైట్, ఏదైనా ఒక ఆబ్జెక్ట్ని, ఇగో ఇక్కడ ఉంది పెన్ను, ఈ పెన్నుని ఇక్కడ నుంచి తీసుకొని ప్యాకెట్లో పెట్టేసుకున్నా. సో ఐ హ్యావ్ డన్ సమ్ వర్క్. ఇక్కడ నుంచి పెన్ను ఇక్కడికి రావాలంటే ఏం చేసిన? ఫోర్స్ అప్లై చేసిన. ఫోర్స్ అప్లైడ్ ఆన్ పెన్ ఓన్లీ. Force applied on pen means particular area, right? So to displacement of any object with the help of application of external force, that is called mechanical work, right? So చూద్దాం వర్క్ డెఫినేషన్స్, యూనిట్స్. సో తర్వాత దేనికి రిలేటెడ్ ఉంటుంది వర్క్, వర్క్ యొక్క ఈక్వేషన్స్ ఏంటి, తర్వాత ఈ రెండింటిని ఇంటర్నల్ ఎనర్జీకి ఎట్లా కోరిలేట్ చేస్తాం, అది ఫస్ట్ లా ఆఫ్ థర్మోడైనమిక్స్కి ఎట్లా డెవలప్ చేశారో చూద్దాం, రైట్? సో దట్ ఈస్ ద వర్క్. వర్క్ ఈజ్ ఏ ఆర్డర్డ్ ఫార్మ్ ఆఫ్ ఎనర్జీ. ఆర్డర్డ్ ఫార్మ్ ఆఫ్ ఎనర్జీ అంటే ఒక సీక్వెన్స్లో జరుగుతుంది అన్నట్టు వర్క్. ఆర్డర్డ్ ఫార్మ్, రైట్? సో ఆర్డర్డ్ ఫార్మ్ ఆఫ్ ఎనర్జీ, right? What is the ordered form of energy? Similar to the definition of heat energy, right? It is a form of energy. Which form? Ordered form of energy. It exchange between system and surroundings. It is exchange between system and surroundings due to other than temperature difference. Other than temperature difference, right? Other than temperature difference. ఇంతకుముందు ఏమన్నాం? హీట్ అంటే టెంపరేచర్ డిఫరెన్స్ ఉండాలి. టెంపరేచర్ డిఫరెన్స్ ఉంటే అది హీట్ ఎనర్జీ అన్నాం. టెంపరేచర్ కాకుండా ఇంకా ఏది ఉన్నా కూడా దాన్ని దేని కింద కన్సిడర్ చేస్తున్నాం? వర్క్ కింద కన్సిడర్ చేస్తున్నాం. పర్టికులర్గా వర్క్ అనేది ప్రెజర్ మీద డిపెండ్ అవుతుంది బట్టి ఏమంటాం? డ్యూ టు డిఫరెన్స్ ఇన్ ప్రెజర్, రైట్? డ్యూ టు డిఫరెన్స్ ఇన్ ప్రెజర్. వర్క్ ఎప్పుడైనా దేన్ని బేస్ చేసుకొని చెప్తాం? దట్ ఈస్ డ్యూ టు డిఫరెన్స్ ఇన్ ప్రెజర్. అదర్ దాన్ ద టెంపరేచర్ మీన్స్ వాట్ వీ హ్యావ్ కన్సిడర్? Pressure difference is there, right? So similarly we will go with the diagram, right? So there is a system is there, right? So this is the system. It has surroundings, right? ఏదైనా సిస్టమ్ అనుకుంటున్నామంటే దానికి సరౌండింగ్ ఉంటుంది, రెండు కలిపితే యూనివర్స్, రైట్? ఓకే, సిస్టమ్ ఉంది, సరౌండింగ్ ఉంది. మరి ప్రెజర్ డిఫరెన్స్ ఎట్లా ఉంది? రెండు ప్రెజర్స్ సేమ్ ఉన్నాయా? సిస్టమ్ ప్రెజర్ ఎక్కువ ఉందా? సరౌండింగ్స్ ప్రెజర్ ఎక్కువ ఉందా? దాన్ని బట్టి మళ్ళీ మూడు కండిషన్స్ వస్తాయి మనకి, రైట్? సో వాట్ ఆర్ దోస్ త్రీ కండిషన్స్ విల్ సీ, రైట్? సో ద ఫస్ట్ కండిషన్ విల్ బి ప్రెజర్ ఆఫ్ ది సిస్టమ్ ఈజ్ గ్రేటర్ దాన్ ప్రెజర్ ఆఫ్ surroundings, right? Pressure of the system is greater than pressure of surroundings. దేని ప్రెజర్ ఎక్కువ ఉంది అన్నట్టు? సిస్టమ్ ప్రెజర్ ఎక్కువ ఉంది. సింపుల్ థింగ్, సిస్టమ్ యొక్క ప్రెజర్ ఎక్కువ ఉంది కాబట్టి ఎటు నుంచి ఎటు పోతుంది ప్రెజర్ అనేది? హై ప్రెజర్ రీజియన్ టు లో ప్రెజర్ రీజియన్. అవన్నీ ఫస్ట్ క్లాస్లో చదువుకున్నాం మనం. హై ప్రెజర్ రీజియన్ టు లో ప్రెజర్ రీజియన్ అంటే సిస్టమ్ నుంచి కొంత ప్రెజర్ అనేది ఎటు పోతుంది? సరౌండింగ్స్కి వెళ్ళిపోతుంది, రైట్? మరి సిస్టమ్ నుంచి సమ్ ప్రెజర్ విల్ బి ట్రాన్స్ఫర్డ్ మీన్స్ వాట్ అబౌట్ ద సిస్టమ్? సిస్టమ్ ఈజ్ గెయినింగ్ ఆర్ లూజింగ్, రైట్? So system is giving some pressure to the surroundings means system is doing some work. So that can be denoted with whenever pressure of system will be more, therefore that is work done by the system, work done by the system. మరి ఈ సిస్టమ్ అనేది వర్క్ చేస్తుంది, ఎవరి మీద వర్క్ చేస్తుంది? వర్క్ డన్ బై ద సిస్టమ్ ఆన్ సరౌండింగ్స్. ప్రెజర్ ఎక్కడైతే ట్రాన్స్ఫర్ చేస్తుందో దెర్ ఈజ్ ఎ వర్క్ డన్ బై ద సిస్టమ్ ఆన్ సరౌండింగ్స్, రైట్? సో వెన్ ఎవర్ ద ప్రెజర్ ఆఫ్ ది సిస్టమ్ విల్ బి మోర్. మరి వర్క్ డన్ బై ద సిస్టమ్, సిస్టమ్ పనిచేస్తుంది కాబట్టి సిస్టమ్ ఎనర్జీ లూజ్ అవుతుందా గెయిన్ చేసుకుంటుందా? వర్క్ చేస్తుంది కాబట్టి. సో ఇట్ విల్ బి లూజ్. వర్క్ డన్ బై ద సిస్టమ్ మీన్స్ హెన్స్ W is equals to denoted with negative. Whenever work done by the system, that becomes W is negative, right? So the second condition is there, right? So what about that second condition? Now pressure of the system is less than of pressure of the surroundings. ఇప్పుడు ఏ కండిషన్? సరౌండింగ్స్ యొక్క ప్రెజర్ ఎక్కువ ఉంది, రైట్? సో సరౌండింగ్స్ ప్రెజర్ ఎక్కువ ఉందంటే ఎటు నుంచి ఎటు మూవ్ అవుతుంది ప్రెజర్? ఫ్రమ్ సరౌండింగ్స్ టు సిస్టమ్, రైట్? ద ప్రెజర్ విల్ బి మూవింగ్ ఫ్రమ్ సరౌండింగ్స్ టు సిస్టమ్. ఇంతకుముందు ఏమైంది ప్రెజర్? దట్ ప్రెజర్ ఇన్ టర్మ్స్ ఆఫ్ ఎక్స్ప్రెసింగ్ ఇన్ టర్మ్స్ ఆఫ్ వర్క్, రైట్? సో ఇక్కడ వర్క్ ఎవరు చేస్తారు అన్నట్టు? సిస్టమ్ చేస్తుంది. ఎవరి మీద? సరౌండింగ్స్ మీద, రైట్? W ఇక్కడ రాస్తున్నా, రైట్? వర్క్ డన్ బై ద సిస్టమ్ ఆన్ ద సరౌండింగ్స్. మరి ఇక్కడ ఎవరు వర్క్ చేస్తున్నారు? వర్క్ డన్ బై ద సరౌండింగ్స్ ఎవరి మీద? ఆన్ ద సిస్టమ్. దెర్ఫోర్ వాట్ ఈస్ ద టర్మినాలజీ విల్ గెట్? వర్క్ డన్ బై ది సరౌండింగ్స్, వర్క్ డన్ బై ది సరౌండింగ్స్ ఆన్ ద సిస్టమ్. మరి సిస్టమ్ పైన పని జరుగుతుందంటే సిస్టమ్ ఎనర్జీని గెయిన్ చేసుకుంటుందా లూజ్ చేస్తుందా? యాస్ ద సిస్టమ్ ఈజ్ గెయినింగ్ ఎనర్జీ. వెన్ ద సిస్టమ్ ఈజ్ గెయినింగ్ ఎనర్జీ దట్ ఈస్ W is equals to indicated with what? Positive. System is gaining energy, right? So one is the condition is pressure of the system will be more, therefore surroundings pressure will be less. There is a work done by the system on the surroundings. Terminology is very important, right? Work done by the system, work done by you అంటే నువ్వు పని చేస్తున్నట్టు కదా, రైట్? సో వర్క్ డన్ బై యూ మీన్స్ యూ ఆర్ డూయింగ్ వర్క్. లైక్ వర్క్ డన్ బై ద సిస్టమ్ ఈస్ గోయింగ్ టు డూ వర్క్. సో ఆన్ ద సరౌండింగ్స్ ఎట్ ద టైమ్ సిస్టమ్ ఈస్ గోయింగ్ టు లూజ్ సమ్ అమౌంట్ ఆఫ్ ఎనర్జీ, హెన్స్ W is equals to negative. Then next, surroundings pressure will be more. Therefore surroundings are doing some work on the system. Work done by the surroundings on the system at that time W is equals to positive, right? Coming to the part of third condition, right? So as we discussed previously, pressure of the system is equals to pressure of external. Pressure of the system is equals to pressure of external means, so there is external part is what? Surroundings. Here we have to discuss, right? Pressure of the system is equals to pressure of the surroundings. As there is a work done, రెండిటి ప్రెజర్ సేమ్ ఉన్నాయి, దెర్ఫోర్ నో వర్క్ డన్. రెండు ప్రెజర్స్ సేమ్ అయినప్పుడు దెర్ ఈజ్ నో వర్క్ డన్. ఎప్పుడైతే వర్క్ జరగలేదో ఆ కండిషన్స్ ఏమంటున్నాం? మెకానికల్ ఈక్విలిబ్రియం. ప్రెజర్స్ సేమ్ ఉంటే ఆ కండిషన్ ఏమంటాం? మెకానికల్ ఈక్విలిబ్రియం. ఈక్విలిబ్రియం కండిషన్ అంటాం దాన్ని, పర్టికులర్గా మెకానికల్ ఈక్విలిబ్రియం కండిషన్, రైట్? దెర్ ఈజ్ నో వర్క్ డన్ మీన్స్ therefore W may be considered as 0. When W is negative, W is positive. When W is 0, so that is depending on the pressure, right? So depending on the pressure means how the work will be depending on the pressure. So how we are going to define the work? then what are the units of work? We have to know in detail about heat and work, then only which will be correlated with thermodynamic properties like internal energy, enthalpy, Gibbs free energy, Helmholtz energy function, and entropy, right? From that only we will get whatever the topics mentioned in our syllabus, so that all the topics will be understand easily if you understand this concept, right? So is it clear, right? This is the work will be denoted with W. Simple thing, this entire concept will be explained or done with only this simple diagram, right? Previously heat energy also will be same. Therefore it is the work is the ordered form of energy, right? So therefore the units of work is a energy form, same units are applicable, joules, calories, ergs, right? So then kilojoules, kilocalories, then kilo ergs. These all are units. Even work units also will be mentioned, that is liter atmosphere also. Liter atmosphere also units of work, that we may particularly work also we may call as pressure volume work, right? So later on in the next classes we will get, whenever we are going to discuss about work means, that is what pressure volume work, how we are getting that relation between the work and pressure with respect to the volume, so that we will see, right? These are the units which will be applicable. And what is the condition we will get here? Mechanical equilibrium will get. In case of heat energy what will get? Thermal equilibrium will get. Thermal equilibrium నుంచి ఏం ఎక్స్ప్లెయిన్ చేస్తున్నాం? జీరోత్ లా ఆఫ్ థర్మోడైనమిక్స్ ఎక్స్ప్లెయిన్ చేస్తున్నాం, రైట్? Then what is actual work, right? So then what is the actual work? Means mechanical work, that we have to define, right? So work or mechanical work. So W, work can be denoted with W. W is equals to force is multiplied with displacement. Force is multiplied with displacement. To displace any object from their original place to other place, what we have to do? We have to apply some external force. With the help of application of external force, the object will be displacement. So how much distance it will be displaced, that will be multiplied with force, that can give the work, right? So therefore W is equals to force into displacement. The force will be F, displacement, small displacement, that will be DL. Therefore this is the W, right? So then now any object possesses some area, that's why that force will be divided with area and multiplied with area and multiplied with DL. F into DL, area get cancelled, therefore we will get again F into DL only. Means by multiplying and dividing with area, there is no change in the value, that is F into DL, right? So then many times we feel pressure. What is the pressure means? That is the definition, that is force per unit area. Whatever is the force which is applied on unit area, that is called pressure, right? So therefore W is equals to pressure into area into length. What about area into length? Volume. Therefore small length is there, that's why small volume. So therefore this is W is equals to PdV, we have to write. W is equals to PdV. Whatever is this pressure that is applicable for system, right? The pressure that is applicable for system. Therefore pressure of system is equals to force per unit area. If area is equals to 1 centimeter square, area is equals to 1 centimeter square, right? 1 centimeter square. Therefore P is equals to F. The corresponding force is equals to pressure. Means whatever the force we have applied on particular unit area, that may be even meter square also we may consider, so that force will be equals to pressure. This force and pressure will be applicable for the system, right? So whenever system pressure, for example if you may consider system, then here is the surroundings, right? System pressure is in this direction, means the surroundings pressure will be in opposite direction, right? So for example, system pressure will be this direction, the surroundings pressure will be in opposite direction. Both system and surroundings are opposite directions, hence this P will be equals to external pressure. If outside pressure we have to write, that becomes minus. If it is plus, that becomes minus. This is P, means P of the system is equals to minus P external, therefore W is equals to minus P into dV we have to write. So D means small displacement. If it is a large displacement is there, therefore W is equals to minus P into delta V. Delta is applicable for the large displacement. So then pressure and volume will be there. So these relations will give the work. That's why we called as pressure volume work. Previously I told that pressure volume work. Pressure volume work, right? So that is called work, right? Work and heat are the what? State functions. Work and heat are the path functions. Work and heat are the path functions. How these path functions are related to the various state functions, so that will give huge information regarding our processes, right? So therefore what we have to remember, the work means we have to remember W is equals to PdV. So when external pressure we may use, so the direction of external pressure will be opposite to the system, therefore hence that will be minus P external into dV, minus P external into dV, or minus P external into delta V, minus P external into delta V. Therefore simply we may call as W is equals to PdV, right? So in all our heat and work, so what we are going to get the information, right? So what we are understand that information means, right? Simple thing, so that we may write in the note, right? Simple thing. First one, heat is observed. If the system heat is observed, so what is the symbol? Q is equals to, observed means Q is equals to positive, right? Heat is released. Heat is released. What about the Q? Q is equals to negative. Heat is released means Q is negative. Heat is observed means Q is gaining, means positive, right? Heat is observed, Q is positive. Heat is released, that is Q is negative, right? So the second one is work done. Work done by the system. Work done by the system on the surroundings, right? Work done by the system on surroundings. Work done by the system means what about the W? W is equals to negative. So then next, work done by the surroundings. Work done by the surroundings on system. On the system. So system is gaining some amount of energy, that becomes positive, right? So these are the terminology we have to remember, right? What is the relation between the heat and work? If heat is observed, Q is positive. If heat is released, Q is negative. If work done by the system, W is negative. Work done on the system, W is equals to positive, right? So when Q is negative, Q is positive. When W is negative, W is positive. Based on this terminology, we will get some questions, right? Whatever the question will be mentioned, just we have to find out the internal energy of the system when some amount of heat is observed and some work done will be done by the system. Heat is observed means Q we have to consider positive. Work done by the system means W we have to consider negative. So these two will be substituted in first law of thermodynamics. Therefore we can get internal energy also, right? So these are the first two, work and heat energy. So with the help of this, somehow other parameters we are going to discuss, right? So what are the other parameters means internal energy. Slowly we are entering to our main topics, right? Internal energy, right? Internal energy. So this is denoted with E, or in some books it is denoted with U, right? Any symbol we have to utilize. Internal energy is E or U also consider, right? U also internal energy, right? So what is meant by internal energy? What is meant by internal energy, right? So simple definition, the energy which is exchanged or the energy which is present in the system, the energy which is present in the system at constant volume. Whatever is the energy which will be present in the system at a constant volume, that will be considered as internal energy. What is meant by internal energy means it is a energy which is present in the system లో ఉంటుంది. ఎప్పుడు అది at constant వాల్యూమ్ కాన్స్టాంట్ ఉన్నప్పుడు ఇంటర్నల్ ఎనర్జీని తీసుకుంటాం, రైట్? సిస్టంలో ఉన్న ఏదైతే ఎనర్జీ ఉందో ఆ ఎనర్జీని, లేదా ఇంకొక డెఫినేషన్ ఏమని చెప్పొచ్చు, ఇంటర్నల్ ఎనర్జీ మీన్స్ ద సమ్ ఆఫ్ all the energies present in the system. మరి all the energies అంటే ఏమంటాం? All the energies ante, so therefore internal energy is equals to sum of potential energy plus sum of kinetic, means the sum of potential energy and kinetic energy, right? Potential energy, kinetic energy, మొత్తం అన్ని ఎనర్జీస్ కలిపి ఏమంటాం? ఇంటర్నల్ ఎనర్జీ. ఇవన్నీ దేంట్లో ఉంటాయి? సిస్టంలో ఉంటాయి. సిస్టమ్ ఈజ్ హ్యావింగ్ ఎనర్జీ internally, that is called internal energy, or the sum of all the energies which are present in the system, that are potential energy and kinetic energy. These kinetic energy may be, right, kinetic energy may be translational energy, rotational energy, vibrational energy, then electronic energy. The sum of all these energies becomes considered as what? Internal energy. This internal energy is denoted with E or U. Internal energy is denoted with E or U, right? So see here, right, this is then units of energy. As we discussed, energy units are what? Joules, calories, then kilojoules, then kilocalories, etc. These are the units. These all are forms of energies. Energy units are same only, so but unit conversions must remember, right? So these are the units for internal energy, right? So how we are going to explain the internal energy, right? So with the help of consideration of system, right? So that will be C, right? So here one system is there, so that will be with the help of first law of thermodynamics also. At that time again I will explain, right? This system is going to absorb some amount of heat energy, that is Q. System is going to absorb. System అనేది కొంత హీట్ని అబ్జర్వ్ చేసుకున్నది. మరి చేసుకుంటే ఏం చేయాలి సిస్టమ్? సో whenever heat is absorbed, the system is going to do work. The system is going to do work. హీట్ని అబ్జర్వ్ చేసుకున్నదంటే ఏం చేయాలి? సిస్టమ్ పని చేయాలి. మరి ఎంత పని చేస్తుంది, రైట్? సో సమ్ ఆఫ్ ది అమౌంట్ ఆఫ్ ఎనర్జీ ఈజ్ యూటిలైజెస్ టు డూ వర్క్. ద రిమైనింగ్ రెస్ట్ ఎనర్జీ ఈజ్ ప్రజెంట్ ఇన్ ద సిస్టమ్, దట్ ఈస్ ఇన్ ద ఫార్మ్ ఆఫ్ ఇంటర్నల్ ఎనర్జీ. Whatever is the rest of the energy which is present in the system, that is called internal energy. That internal energy may be sum of potential energy and kinetic energy, or that may be TE, means translational energy, rotational, vibrational and electronic energies. Right? So here internal energy is E, right? So therefore, so here we have to remember, like internal energy E is exactly the exact value of internal energy E cannot be determined. Then what we have to determine? The internal energy means E or U, that cannot be determined. Means what we have to determine? Means whenever the system and surroundings are there, what is the exchange of energy between them that is happened at constant volume, that is considered as change of internal energy. The exact value or absolute value of internal energy cannot be determined, but what we have to determine, the change of internal energy can be determined. What we have to determine, the change of internal energy. So therefore what we have to say here, the internal energy we cannot determine, but what we have to determine, the change of internal energy we can determine. మరి ఏం సార్ ఇంటర్నల్ ఎనర్జీ అంటే ఇదంతా సమ్ అంటున్నాం, ఏ ఫామ్లో ఉంటుందో తెలియదు కాబట్టి ఆ ఇంటర్నల్ ఎనర్జీని మనం డిఫైన్ చేయలేము. మరి చేంజ్ ఎట్లా డిఫైన్ చేస్తాం, రైట్, ఎనర్జీ ఎక్స్చేంజ్ బిట్వీన్ ద సిస్టమ్ అండ్ సరౌండింగ్స్ విల్ బి టేకింగ్ ప్లేస్. దిస్ ఎనర్జీ ఎక్స్చేంజ్ బిట్వీన్ ద సిస్టమ్ అండ్ సరౌండింగ్స్ at constant volume, that energy will be equals to change in internal energy, right? So simple thing, not only internal energy, any thermodynamic property is there, the absolute values we cannot determine except entropy. మళ్ళీ అందులో ఒకటి ఎక్సెప్షన్ ఉంది, ఎంట్రోపీ. అబ్సల్యూట్ వాల్యూస్ ఆఫ్ ఎంట్రోపీ కెన్ బి డిటర్మైన్ with the help of third law of thermodynamics, but the remaining all thermodynamic properties, exact or absolute value, we cannot be determined. With similar to this, right, similar to this, we cannot determine G, we cannot determine H, enthalpy, we cannot determine A. These absolute values we cannot determine, but what we have to determine, the change of Gibbs energy, change of enthalpy, change of internal energy, this can be determined, right? But in case of entropy, the absolute values of entropies also can be determined. Whenever absolute will be there, the change of entropy also can be determined. So this is, we have to keep it in mind. So, right, this is the most important term. So that is what, the exact value is nothing but absolute values. The absolute values of internal energy cannot be determined, but the change of internal energy can be determined. So for measurement of internal energy, so one experiment is there, that is also we are going to discuss, that is what, bomb calorimeter. With the help of bomb calorimeter we can get the internal energy, right? That is particularly change of internal energy. So this is about concept of internal energy, right? So then we'll see, based on that internal energy, so the type of reactions also we may explain, right? So delta E we have to define, delta E, this we have to define. What is meant by delta E, right? So delta E means change in internal energy, right? So this is the energy exchange, this is the energy exchange between system and surroundings, at constant volume. So that is called change in internal energy, right? So therefore delta E can be written as heat energy, that is exchange of heat energy at constant volume, right? So this is the heat at constant volume, that is called change of internal energy, heat of reaction at constant volume, that is change of internal energy, that will be equals to QV, right? Heat is the what, that is due to temperature difference. The exchange of heat energy between the system and surroundings due to temperature difference, so that will be considered as delta E, If this delta E will be positive or delta E will be negative, so the what will happen, that we are going to apply for a reactions. For example, any reaction is there, reactants which are gives rise to products, right? This is a general reaction. ఏదైనా జనరల్ రియాక్షన్ ఏం తీసుకుంటున్నాం, రియాక్టెంట్స్ ఆర్ గివ్స్ రైస్ టు ప్రొడక్ట్స్, మరి ఈ రియాక్టెంట్స్ ఎనర్జీని అబ్జార్బ్ చేసుకొని ప్రోడక్ట్స్కి కన్వర్ట్ అవుతున్నాయా హీట్ని, లేదా హీట్ని రిలీజ్ చేస్తూ ప్రోడక్ట్స్కి కన్వర్ట్ అవుతున్నాయా చూద్దాం. రైట్, సో దట్ విల్ బి ఫస్ట్ వన్. రియాక్టెంట్స్ ఆర్ అబ్జార్బింగ్ సమ్ అమౌంట్ ఆఫ్ హీట్ ఎనర్జీ దెన్ కన్వర్టెడ్ టు ప్రోడక్ట్స్. రైట్, మరి రియాక్టెంట్స్ యొక్క ఎనర్జీ 20 జౌల్స్ అనుకుంటున్నా. రియాక్టెంట్ ఎనర్జీ ఎంత? 20 జౌల్స్. మరి ఎంత హీట్ ఎనర్జీ ఇస్తున్నా? 10 జౌల్స్. అప్పుడు ఈ మొత్తం 20 జౌల్స్ ప్లస్ 10 జౌల్స్ కలిపి ప్రోడక్ట్స్ యొక్క ఎనర్జీ ఎంత అవుతుంది? 30 జౌల్స్. 30 joules. By giving 10 joules of energy to the reactants, we can get the products, right? So therefore, how we'll get for this reaction? Delta E means energy of products minus energy of reactants. Energy of products minus energy of reactants. How we'll get the change of energy? ఎనర్జీ చేంజ్ అనేది ఏదైనా జనరల్గా రియాక్షన్కి ఎట్లా వస్తుంది? ప్రోడక్ట్ ఎనర్జీ మైనస్ రియాక్టెంట్ ఎనర్జీ. వాట్ ఈస్ ద ప్రోడక్ట్ ఎనర్జీ హియర్? Right? So product energy is 30 joules. Product energy is 30 joules. 30 joules minus reactant energy enta 20 joules. Right? So 30 minus 20 how much? 10 joules. Delta E ఎంత వచ్చింది మనకి? 10 joules వచ్చింది. మరి ఇక్కడ హీట్ ఎంత తీసుకున్నాం? 10 joules. మరి డెల్టా E is equals to Q అని రాయొచ్చా? డెల్టా E is equals to Q. This is when volume will be kept constant. Delta E will be QV, right? So here delta is equals to QV means heat at a constant volume. At constant volume QV, that is 10 joules. Delta E will be 10 joules, right? So therefore delta E is equals to QV, right? So this is the change of internal energy. Whenever heat energy is observed, hence that reaction is called as what? Endothermic reaction. Endothermic reaction. For endothermic reaction, delta E will be what we have to consider? That will be positive. This is also we have to remember. For endothermic reaction, delta E will be positive and delta E is equals to QV. All this terminology we have to utilize, right? Okay. Next, one more condition I am taking. That is the second condition. The reactants which are converted to products by releasing some amount of heat energy. That is the second condition, right? That is the condition is what? Second condition, right? So therefore, here reactant energy will be 30 joules. How much reactant energy? 30 joules, right? So then here product will be 20 joules. Then heat will be how much? It will be released? 10 joules, right? How much energy will be released? That is 10 joules. Therefore, here the change of internal energy delta is equals to E of products minus E of reactants. E of product is what? 10 joules minus E of reactant is 30 joules. Therefore, what we are getting? Minus 10 joules. So here heat is released means that we may have written as negative. Therefore, this negative indicating what? Released. Negative indicating released, then the released energy will be 10 joules. Here will be 10 joules. Therefore, delta E is negative. Delta E is negative. That means such a process is known as what? Exothermic process. Exothermic process, right? Whenever delta E is positive, that becomes endothermic process. Delta E is negative means exothermic process, right? So that is in terms of internal energy. This is the concept of internal energy. Internal energy, right? Similar to this, we have to explain about the enthalpy also, right? So same conditions that will be applicable for enthalpy also, but how we have to define that enthalpy, right? So that will be C, right? So with the help of enthalpy, we are able to get first law and second law of thermodynamics equations, right? Okay, right. So that is enthalpy. This is the concept is very important of enthalpy. Enthalpy is denoted with H, capital H. This is also called as heat content of the reaction. Heat content of the reaction. Heat content of the reaction, right? How we are going to define this enthalpy of the reaction? So that is in terms of internal energy, right? So whatever is the internal energy is there, right? So H will be defined as, right, we have to remember this equation. H will be defined as internal energy plus PV. This PV is what? Pressure, volume, work, right? Means heat content. H is the what? Heat content. Heat content of the system, right? So that here I will explain, right? So system is there. The system is going to absorb some amount of heat energy, that is Q. Then this is going to do work. The rest will be present in the form of internal energy. What is meant by first law of thermodynamics means the sum of internal energy and work, which is equals to how much amount of heat energy is absorbed by the system. How much amount of heat energy is absorbed by the system. That is called first law of thermodynamics. So we will discuss again. Internal energy will be E. Then Q is equals to internal energy plus W. Q is equals to internal energy plus internal energy is equals to Q plus W we have to consider, right? Means whatever is the internal energy is there, that is also we have to consider, but approaching will be different only, right? Internal energy, whatever is the internal energy is there, that will be how much amount of heat is observed and how much work done will be there. The sum of that two will be equals to what? Internal energy. So therefore hence internal energy E is equals to what we have to write? Q plus W. Internal energy is equals to Q plus W. That is the from the first law of thermodynamics, right? Means what we are considering here, see, Q is the heat, right? This Q will be equals to internal energy. So when pressure, volume, work will be there, the sum of this internal energy and pressure, volume, work, right? So this will be, the pressure will be, already we know P is equals to work done by the system means minus PdV. Therefore E is equals to Q minus PdV we have to write. E plus PdV is equals to Q. This Q is nothing but heat content of the system, that is the enthalpy, right? So that we are going to define here, right? So means enthalpy H is the internal energy plus pressure, volume, work. The sum of these two, right? Internal energy and pressure, volume, work. These two will be equals to what? Heat content of the system. That is called enthalpy, right? E is a internal energy. This is internal energy. Then H is a enthalpy. H is a enthalpy. H is equals to E plus PV, right? If you may consider at constant pressure, right? At constant pressure, right? So what is meant by that? Delta H is equals to delta E plus constant pressure means P delta V will get. Delta H is equals to delta E plus P delta V, right? At constant pressure. So this is UV method, P delta V and V delta P we will get. So at constant pressure delta P will be equals to 0. Hence the second term will be 0. Therefore we will get the relation is delta H is equals to delta E plus P delta V, right? So delta H is change in enthalpy. What about enthalpy? H only. As I said previously, H is the absolute value that cannot be determined, but what we have to determine? Delta H only can be determined. Delta H only can be determined. What is meant by delta H means change in internal energy plus pressure, volume, work. So the sum of these two will be equals to delta H, right? So hence we are going to define delta H also, right? Delta H, how will define delta H means it is the energy, exchange between system and surroundings. It is a energy exchange between system and surroundings, right? At constant pressure, right? So simply we have to written as delta H is equals to QP. Q is a heat energy which is exchanged at where? At constant pressure. At a constant volume will be internal energy, at a constant pressure will be enthalpy. This we have to remember. So therefore it is heat of reaction. Heat of reaction at constant pressure. Heat of reaction at constant pressure, that is known as what? Enthalpy. Change of enthalpy. Right? So there is a one instrument experiment is there to measure the delta E and delta H both. So that is bomb calorimeter and water calorimeter, or else so type 1 calorimeter and type 2 calorimeter. Two different kind of calorimeters are there. That calorimeters are required to get the change of internal energy and enthalpy of the systems. The change of internal energy and enthalpy of the systems. Right. So then here, so similarly, which is applicable for enthalpy also energy only, therefore the units are same applicable. And how it will be applicable for the reactions? With the help of this we are going to get exothermic phenomenon and endothermic phenomenon. So as you know that for exothermic, what about the change of delta E and delta H, right? Similarly for a general reaction, right, the reactants are gives rise to what? Products. Therefore the change of enthalpy delta H can be HP minus HR. That means enthalpy of products minus enthalpy of reactants. Enthalpy of products minus enthalpy of reactants, right? So by considering one reaction, the reactants by absorbing some amount of heat energy then converted to products. So therefore this is 25 joules, right? With 25 joules, this is 10 joules, then product will be 35 joules, right? Therefore delta H will be what? H of products minus H of reactants. H of products is 35 minus 25, that becomes 10 joules. These 10 joules will be equals to absorbing heat energy. This entire process is carried out at constant pressure only. So therefore hence delta H is equals to Q of P. Right? So therefore here positive sign we are getting, so hence delta H is equals to positive. So this is the reaction is known as endothermic reaction. As similar to delta E, this is endothermic reaction, right? Endothermic reaction. Similarly, so the reaction will be carried out with the liberation of some amount of heat energy, right? So that means other kind of reaction, reactants are gives rise to products by liberation of some amount of heat energy. So for example here 35 joules of heat energy is there, 25 joules of products, then 10 joules of heat energy is liberated. Therefore delta H can be written as, right, H of products minus H of reactants, that is 25 minus 35, that becomes minus 10 joules. This minus is a releasing, therefore which will be 10 joules will be equals to Q. So therefore hence in this case also delta H is equals to Q of P. Right? The exchange of heat energy between the system and surroundings or between the reactants and products, so that is at constant pressure, that will be considered as change of enthalpy. But here negative we are getting, delta H is equals to negative. So therefore such reaction is what? Exothermic reaction. Exothermic reaction. So this is about what? Delta H. As similar to the delta E, delta H also, how it will be correlated with heat energy. As I said, state functions are relation with path functions. H and E are the state functions. How that will be correlating with path functions of heat energy. Next we have to correlate with work done also, right? So therefore this is the delta H is negative, delta H is positive, right? So hence the equation will be delta H is equals to delta E plus P delta V. So that is also, from that we will get some more equations, right? So from that we will get some relations also. How it will be related to that we'll see, right? So that is, we know that delta H is equals to delta E plus P delta V. Delta H is equals to delta E plus P delta V, that we know that, right? So then from ideal gas equation, From ideal gas equation, we know that ideal gas PV is equals to RT. This is applicable for 1 mole. For n mole, PV is equals to nRT. PV is equals to nRT. This is applicable for n mole. 1 mole kemo RT, n moles means nRT. Right. At a constant pressure, pressure constant అంటున్నాం. అప్పుడు ఏం చేంజ్ అవుతుంది? వాల్యూమ్ విల్ బి చేంజెస్. మరి అప్పుడు నంబర్ ఆఫ్ మోల్స్ విల్ బి చేంజెస్ వెన్ టెంపరేచర్ ఈజ్ కాన్స్టాంట్, ఆర్ వెన్ ప్రెజర్ ఈజ్ చేంజెస్, when pressure is constant, volume is changes, number of moles are constant, gas constant, then temperature will be changed, right? So therefore P is equals to what we have to consider? Either delta n RT or nr delta T. Here number of moles will be constant, therefore change in temperature considered. Here temperature is constant, number of moles will be changes, right? So many ideal gas equations are there that we will explain with the help of thermodynamic processes, right? So what is meant by thermodynamic process, at that time we will get. So these will be substituted in above equation. So therefore we will get delta H is equals to delta E plus delta N RT. Therefore we can get the relation between delta H and delta E. How delta H and delta E will be related with each other, right? If delta N is 0, right? So there one case delta N is 0. When delta N is 0 means this entire term will be 0. Hence delta H is equals to delta E, right? If delta N is equals to positive, right? If delta N is positive, so this is the positive value, means for this delta E we are adding some value, then only it will be equals to delta H, means, right, delta H is greater than delta E, right? If delta N is equals to negative, right, so negative, delta H is less than of delta E, right? So these are the relations between delta H and delta E will get, right? Delta H and delta E relations we will get. Like that, use conversions are there, simple thing. So one concept to other concept means ఒకటి తెలిస్తే ఒకదాన్ని ఇంకో దానికి కనెక్ట్ చేయొచ్చు, దాని నుంచి ఇంకోటి కనెక్ట్ చేయొచ్చు, దాని నుంచి ఇంకోటి కనెక్ట్ చేయొచ్చు. అట్లా నంబర్ ఆఫ్ కనెక్టివిటీస్ చేసుకుంటూ పోతే మన కాన్సెప్ట్ అనేది ఈజీగా వచ్చేస్తుంది. ఇట్ ఈస్ ద కనెక్టివిటీ టాపిక్ ఓన్లీ. ఫస్ట్ డే ఏదైతే చెప్పినామో అది లాస్ట్ క్లాస్, థర్మోడైనమిక్స్ క్లాస్ వరకు కూడా ఆ టాపిక్ని యూజ్ చేస్తూ పోతుంటాం, రైట్? సో దెర్ఫోర్ దిస్ ఈస్ ద ఈక్వేషన్ వీ హ్యావ్ టు రిమెంబర్. ఇఫ్ ఎనీ రియాక్షన్ విల్ బి దేర్, దెన్ హౌ టు కన్సిడర్ డెల్టా ఎన్, రైట్? సో ఐ విల్ ఎక్స్ప్లెయిన్ consideration of delta n. With that I will conclude and I will discuss some numericals based on this, right? So that is delta n will be number of moles of gaseous products, number of moles of gaseous products minus number of moles of gaseous reactants, number of moles of gaseous reactants, right? So number of moles of gaseous products, then number of moles of gaseous reactants, means delta n can be is applicable for only gases. If solid is there, liquid is there, right? So we want to consider that will be applicable for what? Only gases. Particularly gases are involved in the reaction. So therefore delta n can be we can get, right? So that we'll explain with one example and we'll conclude that, right? So relation between delta E and delta H for the following reaction, right? So what is the example, right? We'll see. Dissociation of HI. Dissociation of HI, that means 2 moles of HI is dissociates into H2 molecule plus I2 molecule. This HI will be gas, H2 will be gas, then I2 will be gas. Okay, right. First what we have to consider? Delta n, number of moles of products. What about number of moles of products? Here 1 mole is there, here 1 mole is there. Here how many? 2 moles are there. So that is 1 plus 1 products minus 2 reactants, that is 2 minus 2, that becomes 0. When delta n is 0, the relation between delta H is equals to delta E plus delta n RT. So delta n is 0 means, therefore in this condition delta H is equals to delta E. In this condition delta H is equals to delta E, right? So this is the one example we will get the relation, right? So next one more reaction I will give. Haber process, many times it will be utilized, right? The synthesis of ammonia in Haber process, right? So that is N2 is combined with H2, so that can be produces NH3. That can be produces NH3. So these all are gases, gas and this is the gas molecule, right? Or else not only equilibrium condition, we may take directly reaction, right? So all are gases, right? How many moles of this we have to take? 3 moles of hydrogen and 2 moles of ammonia will get. So therefore here we have to calculate delta Ng. Delta Ng means what are the number of products? Number of moles of products will be 2. Number of moles of reactants will be 3 and here will be 1. Therefore 2 minus 3 plus 1, that is 2 minus 4, that is minus 2. Delta Ng is minus 2. Therefore what is the relation? Delta H is equals to delta E plus delta Ng RT. Delta Ng RT, right? Delta Ng is minus 2 means delta H is equals to delta E minus 2 RT, right? Delta E minus 2 RT. Some value we are removing from this, right? So means hence delta H is less than of delta E. This is the relation we will get. Here in this case delta H is equals to delta E, but here delta H is less than of delta E. So how we are getting this delta H and delta E? With the help of bomb calorimeter and water calorimeter. From that how we are getting the questions, based on that will be discussed, right? So చాలా ఈజీ అండి, కనెక్టివిటీ చేసుకుంటూ వెళ్ళడమే. ప్రాపర్గా సబ్జెక్ట్ అర్థం చేసుకోవాలి. సో డీటెయిల్గా వెళ్తున్నాం. సో ఆ టర్మినాలజీ అర్థం చేసుకోవాలి, ఇచ్చిన క్వశ్చన్ అనాలిసిస్ చేయాలి, ఏ ఫార్ములా సూటబుల్ అవుతుందో అది తీసుకోవాలి, దాన్ని సబ్స్టిట్యూట్ చేయాలి. సో దాని నుంచి మనకు కావాల్సిన ఇన్ఫర్మేషన్ వచ్చేస్తుంది, రైట్? సో దిస్ ఈజ్ ద టాపిక్, టుడేస్ టాపిక్, రైట్? సో విల్ కంటిన్యూ దిస్ వన్ ఇన్ ద నెక్స్ట్ క్లాస్.